This section is all about finding integrals of trigonometric functions, maybe products of trigonometric functions. And there are a few patterns that you need to recognize so that you can employ the correct method. But in general, it is using the geometry between trigonometric functions to simplify with some algebra via a substitution. One of those such tricks is noticing that when you have an odd power of sines or cosines, is to use one of those odd powers in your substitution. So I'm going to rewrite this. And that sine cubed, I'm going to write as sine squared times an extra sine. The cosine squared of x is already there for us. So I basically just rewrote this cube as sine squared times sine. And it's because it was odd that I want to do this. I can rewrite the first sine squared using the Pythagorean identity as 1 minus cosine squared. And I can multiply sine and cosine squared in any order that I want to. So I'm just going to bring the cosine squared to the left and the sine of x to the right. So I peeled off one of the powers from the odd number of sines, and that is what I'm going to use as my substitution. I'm going to replace cosines. So if u is equal to cosine, then du will be equal to minus sine of x dx. And it is that sine of x dx that I'm going to replace. So replacing all of my cosines with u's, I have 1 minus u squared times u squared. And the sine of x dx is replaced by a negative du. So we turned a complicated integral of the product of 3 sines and 2 cosines to really just a polynomial that we have to integrate. This is going to be minus integral u squared minus u to the fourth, which I can just replace as u to the fourth minus u squared by negating everything. That's just because I don't want that leading negative out there. And this anti-differentiates as 1/5 u to the fifth minus 1/3 u cubed with an arbitrary constant. And I will replace all of my u's with x's via the relationship u is equal to cosine of x. So we have 1/5 cosine to the fifth of x minus 1/3 cosine cubed of x plus c. So anytime you have an odd number of sines or cosines, peel one of them off to be used in a substitution.